The main purpose of a standard branch circuit breaker, such as a Q120, is to automatically interrupt the flow of electrical current when that current exceeds a predetermined level. This interruption is critical for preventing damage to electrical equipment and, more importantly, for preventing electrical fires. The circuit breaker acts as a safety device, monitoring the current flowing through the circuit it protects. When the current reaches a point that is considered excessive, the breaker trips, effectively cutting off the power to that circuit. This predetermined level is based on the ampere rating of the circuit breaker, which is clearly marked on the breaker itself, such as a 15 amps, 20 amps, or 30 amps breaker. The National Electrical Code, or NEC, Article 240.4. It specifically addresses this function, stating that overcurrent protection shall be provided to prevent excessive heating due to overloads or fault currents, which may cause fires. An overload condition occurs when the current in a circuit exceeds the rated ampacity of the conductors or the connected equipment. This can happen when too many devices are plugged into a single circuit, drawing more current than it is designed to handle. Excessive current causes the wires to heat up, which can damage the insulation and potentially start a fire. A fault current, on the other hand, is a more severe condition where there is a short circuit between two conductors or a conductor and ground. This results in a very high current flow that can cause immediate damage to equipment and pose a significant fire hazard. Circuit breakers are designed to respond quickly to both overload and fault current conditions. They use different mechanisms to detect and interrupt these types of overcurrents. For overload protection, a thermal element, such as a bimetallic strip, is often used. This strip heats up as current flows through it. When the current exceeds the breaker's rating, the strip bends and triggers the tripping mechanism. For fault current protection, a magnetic element is typically used. This element responds to the sudden surge of current by creating a magnetic field that trips the breaker almost instantaneously. The speed at which a circuit breaker trips is crucial in preventing damage. In the case of a fault current, the breaker must trip within milliseconds to limit the amount of energy released into the circuit. This prevents arcing, which can ignite nearby materials and cause a fire. The NEC provides detailed requirements for the selection and installation of circuit breakers. These requirements are based on the type of circuit, the ampacity of the conductors, and the characteristics of the equipment being protected. For example, a 15 amp circuit breaker is typically used for general lighting and receptacle circuits in residential buildings. A 20 amp circuit breaker is often used for kitchen and bathroom circuits, which may have higher loads. Larger circuit breakers, such as 30 amps, 40 amps, or 50 amps breakers, are used for appliances like electric ranges, dryers, and air conditioners. It is important to select the correct size circuit breaker for the circuit it is protecting. Using a breaker that is too large can allow excessive current to flow, defeating the purpose of overcurrent protection. Using a breaker that is too small will result in nuisance tripping, where the breaker trips unnecessarily even under normal load conditions. The NEC also specifies the types of conductors that must be used in electrical circuits. The conductors must be rated to carry the amount of current that the circuit breaker is designed to protect. For example, a 15 amp circuit typically uses 14 American wire gauge or AUG copper conductors, while a 20 amp circuit typically uses 12 AWG copper conductors. Larger conductors are required for high amperage circuits. In addition to protecting against overloads and fault currents, circuit breakers also provide a convenient way to disconnect power to a circuit for maintenance or repairs. By simply flipping the breaker to the OFF position, the power to the circuit is safely interrupted. This eliminates the need to remove fuses or disconnect wires, making it easier and safer to work on electrical equipment. Circuit breakers are an essential component of any electrical system. They provide critical protection against overcurrents, preventing damage to equipment and preventing fires. By understanding the function of circuit breakers and following the requirements of the NEC, one can ensure the safety and reliability of electrical systems. The proper selection and installation of circuit breakers is crucial for protecting people and property from the hazards of electricity. Firstly, understanding the type of circuit is crucial to deciding which circuit breaker to use. Secondly, checking the rated amperage of the conductor is critical. Thirdly, understanding the nature of the load and equipment. The circuit breaker serves as a rapid response mechanism for circuit protection. If it's properly installed and connected to proper ground, it will prevent current from damaging equipment connected to the circuit, as well as potentially mitigate fire hazards. Overcurrent protection is there to protect the wires themselves. Without this overcurrent protection, the wires can melt the insulation and create a fire, or melt completely, causing equipment damage in the process. Remember to always check with a qualified electrician to ensure you are using the appropriate circuit breakers for the application. In addition, it's important to remember that the circuit breaker is only part of an overall electrical safety plan that includes proper wiring practices, grounding, and the use of other safety devices, such as ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs. These devices provide additional protection against electrical shock and arc faults, which are common causes of electrical fires. The use of circuit breakers is based on a straightforward, yet effective principle. As current passes through the breaker, it generates heat. A bimetallic strip within the breaker reacts to this heat. If the current exceeds the breaker's rated amperage, the bimetallic strip bends due to the excessive heat. This bending action triggers the tripping mechanism, which causes the breaker to switch off, interrupting the flow of electricity. In cases of a short circuit, the current rises almost instantaneously to extremely high levels. In such situations, the electromagnetic component within the circuit breaker comes into play. The sudden surge of current creates a strong magnetic field that quickly activates the tripping mechanism. This rapid response is vital to prevent severe damage and fire hazards that can result from a short circuit. Circuit breakers come in various sizes and types, each designed for specific applications and voltage levels. Standard residential circuit breakers are typically rated for 120 volts or 240 volts. Higher voltage systems, such as those found in commercial and industrial settings, require circuit breakers with appropriate voltage ratings. It is essential to use circuit breakers that are specifically designed and rated for the electrical system in which they are installed. Attempting to use an incorrectly rated circuit breaker can lead to dangerous situations and equipment failure. The NEC provides comprehensive guidelines for selecting the correct type and size of circuit breakers for various applications. These guidelines take into account factors such as the circuit's voltage, amperage, and the type of load it will be serving. Following these guidelines is essential to ensure the safety and reliability of electrical systems. Proper maintenance of circuit breakers is also crucial to ensure their continued functionality and safety. Circuit breakers should be periodically inspected to ensure that they are in good working condition. Any signs of damage, such as cracks, corrosion, or loose connections, should be addressed immediately. Circuit breakers should also be tested periodically to verify that they are tripping correctly under overcurrent conditions. This testing can be performed using specialized equipment and should be carried out by qualified personnel. Replacing circuit breakers is also important. Circuit breakers have a limited lifespan and can degrade over time due to repeated use and exposure to environmental factors. It is recommended to replace circuit breakers every 25 to 30 years, or sooner if they show signs of wear or damage. When replacing circuit breakers, it is essential to use the correct type and size of replacement. Using an incorrect replacement can compromise the safety of the electrical system. If you are not comfortable replacing circuit breakers yourself, it is always best to hire a qualified electrician to do the job. Always remember that working with electricity can be dangerous. It is important to take precautions to protect yourself from electrical shock. This includes turning off the power to the circuit before working on it, using insulated tools, and wearing appropriate personal protective equipment. If you are not familiar with electrical safety procedures, it is best to consult with a qualified electrician. Electricity is a powerful force that must be treated with respect. By following the guidelines and best practices outlined above, one can safely and effectively use circuit breakers to protect electrical systems and prevent fires. Furthermore, one should never attempt to bypass or disable a circuit breaker. Circuit breakers are designed to protect electrical systems from overcurrents, and tampering with them can create a dangerous situation. If a circuit breaker is tripping frequently, it is important to investigate the cause of the problem and correct it. This may involve reducing the load in the circuit, replacing damaged wiring, or upgrading the circuit breaker to a larger size. In some cases, it may be necessary to install a new circuit to accommodate additional electrical loads. The purpose of a circuit breaker is to protect circuits.